Up next, we've got a topic that I know a lot of people, a lot of security teams are struggling with, and that is Kubernetes security. And to talk all about attacking and defending Kubernetes clusters, we've got Magno Logan here, who is a security specialist at Trend Micro, but he's been doing a lot of work over the years, not only in cloud, but containers, application security, corresponding research. And Magno is also a member of the CNCF, the Cloud Native Computing Foundation's Security Technical Advisory Group. So very much looking forward to this and hearing all about Kubernetes security. So Magno, I'm going to turn it over to you.
Thank you. Thank you, Frank. Thank you, everyone. Hello, good morning, good evening, good afternoon. Thank you for joining. As Frank said, my name is Magno Logan, and I'll talk about Kubernetes security, attacking and defending Kubernetes clusters. Okay, I have the slides. Okay, good. Okay, so just a little bit about myself. I'm an information security specialist and senior threat researcher at Trend Micro here in Canada. I do cloud and container security research, as he said, member of the CNCF tag security team, which is like an open community that everyone can join and learn about and participate. So if you want to learn more, just let me know. I don't consider myself a Kubernetes security expert yet. I've been studying Kubernetes over the past year now, but there's still a lot of stuff to learn, right? And I have a personal blog there at k8s.com with some monthly articles that I try to post about application security, DevOps, DevSecOps, and Kubernetes security as well. Okay, sounds good. So this is the agenda for us. I know it's a lot to cover in 30 minutes. I'll do my best to try to cover everything. If not, we can always chat on the Slack channel there, and I'll share the slides and everything later. Okay, so before we start, I dropped a few links on the Slack channel already, so feel free to check them out. One of the main links that I posted is this awesome Kubernetes security list. That's the one of the list that I created when I was researching and studying about Kubernetes and Kubernetes security. And there's so much stuff out there and everything is kind of scattered around. So it was hard for me to go back and find those links and find those great resources. So first I had like a small text file on my computer, and then I decided, okay, maybe if I do publish that and share on a GitHub, people will contribute and will enjoy it as well. So that's that. Okay. So yeah, talking about the MITRE ATT&CK framework, right? So oops, sorry. Yep, okay, good. Okay, so talking about the MITRE ATT&CK framework, what is that, right? What is the MITRE ATT&CK framework? What does that mean? I'm pretty sure that most people are aware of it already, right? It's a global accessible knowledge base of opposing tactics and techniques based on real world scenarios, right? So that's the key here of the attack framework. It's based on real world scenarios. It's not POC. It's not just a threat model. It's things that attackers are doing on real world organizations or even in honeypots or honeynests, whatever you call it, right? So it's used as a basis for development of specific threat models and methodologies in many different scenarios. And it can be used not just for defending your organization and your systems, but also for attacking them as well, right? So since last year, we didn't have MITRE Matrix for containers, right? We had one for Windows, for Linux, and even for the cloud, but we didn't have one for containers and also Kubernetes, I would say. But Microsoft has published kind of a Kubernetes Threat Matrix in April last year, and they recently updated that as well, which is not an official MITRE framework, but it's a really good source of information of tactics and techniques that attackers are using, and they're seeing in the wild, especially data from their own cloud environment, Azure, right? So there's a lot of information, and that was used as a baseline for the MITRE ATT&CK for containers. So I'm gonna tell a little bit of how that MITRE ATT&CK for container framework started, and it was created from my perspective. So, okay, here, yeah, good. So Jen Burns, which was the technical lead for the MITRE ATT&CK for cloud and also containers, reach out to the community in December last year, asking for help and for data around this container vulnerabilities, container techniques, and container attacks, right? From real world scenarios and honeypots and whatever you had, right? So our team has been researching Docker and recently, since last year, Kubernetes with some honeypots, some real world scenarios since 2018 on Docker specifically, right? So we have several honeypots out there that we monitor and we analyze what the attackers were doing. So right away, we provided this data to MITRE. We reached out to Jen Burns and we provided them with all the knowledge, all the articles and all the data that we had related to this, to those attacks, those techniques and scripts and all that stuff. So that was really interesting. It was really nice. So we started working with MITRE since December, and the first release of this framework was published on February this year. And now this official matrix here, the MITRE ATT&CK for containers, and I say also Kubernetes, because there's also some stuff that are very specifically to Kubernetes clusters. So that was published April this year, 29th of April. I don't know if everyone has heard about it. So now we have that. So we can start designing and protecting your environment and maybe planning some red teaming or purple teaming exercises on containerized and clustered environments based on that. So that's really nice. And what's cool about it is that we contributed with 7 techniques for this matrix. So kind of 25%, a quarter of the matrices. And 2 of those techniques were brand new. They didn't exist on the MITRE Enterprise or anywhere. So that's really nice. So before that was last year when I was doing started my own research on Kubernetes. I created my own threat model on kind of a scenario, an attack into a cluster, right? So basically, one of the possibilities of getting access to a cluster, right? You have the Kube API server is one way, but you also have vulnerable web applications, right? That's what they're running in a cluster. You're running maybe many different web applications, and some of them are exposed to the internet, right? And if those applications have vulnerabilities, right, your cluster can also be compromised, right? Depending on, of course, the configurations, all the permissions that are set in your cluster. And we're going to talk about that soon. So this threat model I did even before the MITRE ATT&CK for a container was even discussed. I did it last year. Basically, the scenario here that we're going to talk about, you have a web application that's vulnerable to RCE vulnerability, right? A remote command execution. And that get exploited, and then the attacker get a shell inside the pod, right, inside the cluster, and from that, he or she can do any kind of reconnaissance to understand if he's in a containerized environment and how to do that, and then proceed to doing some lateral movement and escalating privileges to get secrets, to get access to API keys that you can do that from inside the pod. As well, you can reach the instance metadata from inside the pod, and even compromise the whole cloud environment, right? If you're running on a cloud environment, in this situation here, I did the model based on an EKS environment, right? So we of course we modeled that, and that's very pretty and nice and colorful, right? But like we wanted to test it, right? So we deployed our honeypots in our real world clusters in the wild, and we exposed the web application that was vulnerable to RCE, and we waited. And it didn't take long for the attackers to find it and to compromise it, right? So the first honeypot that we deployed, it took less than 24 hours for the attackers to compromise the web application, get access to the cluster, break out of the container because they had privileged access, and compromise the whole cloud environment and start deploying huge instances to mine cryptocurrencies, right? Luckily, we were monitoring that environment, so we shut that down right away, and we didn't get a huge AWS bill, right? So I'm going to describe what happened here. So yeah, basically, you have a web application. In this case here was a Drupal outdated web application based on version 8.5.0, which is vulnerable to RCE called Drupal Gaddon 2, if I'm not mistaken. And basically, okay, we designed something to make it kind of a website, a blog, or something talking about cryptocurrencies, right? So here's the scenario, right? You have a public exploit, not just on Metasploit and on GitHub, that can compromise this web application. It's not that old exploit. It's from 2018, so kind of 3 years old almost. But there's also other ways to attack a cluster as well, as we saw in the matrix, right? You have the Kube API server, if that's exposed and misconfigured, and you used to have the dashboard, which was installed by default on Kubernetes, and luckily that's not the case anymore. But some clusters that are still out there, they are outdated, and they have this dashboard exposed by default. So be very careful with that. With the exploitation execution phase here, right? If you can reach the API endpoint externally, and I think that's something that pretty much everybody that's studying Kubernetes security, they talk about. Yeah, don't expose your API server, your Kube API server, right? Don't expose that if you don't know what you're doing, and if you don't have the proper permissions, right? Attackers will find that. And as the example that I mentioned, it was less than 24 hours that they did, and we didn't publish the URL of our cluster anywhere, right? We just created a cluster, and by default on EKS, that API server is publicly accessible, right? So anyone that hits that endpoint, they know that they get a response, and they know that there is a Kubernetes cluster on that IP and port, right? So from that, we executed the exploit that I mentioned on the previous slide, which is available on GitHub, right? And we got the shell inside a pod, right? So what can we do from there, right? Besides, before I talk about that, there's also an awesome tool from Aqua Security. That's an open source tool that hunts for Kubernetes security weaknesses in Kubernetes clusters. You can just download it and use it, just point it to your Kubernetes cluster, your API server, and we'll find a lot of issues and misconfigurations already. It's very helpful for assessing your own cluster or a cluster that you have permission to test. Okay, so yeah, going back to the attack there, what can you do once you get a shell inside a pod? How do you know that you're inside a Kubernetes cluster and you're inside a container, right? What can you do there, right? So one of the things that you can check to is the environment variables, right? So there is an easy command here, just checking for the Kubernetes environment variables, and probably every pod will have should have those variables there, because they need to reach the API server, right? So you will right away you see that you're in a Kubernetes environment. Another thing is the service account token, right? If that's hard coded in the pod, which is usually by default, you can find right away the service account token that's used by the pod to talk to the API server. So that's two indicators that you're on a Kubernetes cluster. If you still don't know, if you couldn't find that information, there is an awesome tool that's also available on GitHub that's called MITRE. That's a container introspection tool, right? You can find out what container runtime is being used, as well as the features available. So if you download into the pod that you're in and execute it, it's gonna tell you, okay, this is a clustered environment, it's a containerized environment, you're running a Kubernetes or Docker. It's gonna tell you the capabilities, and if the SecComp and API Armor are set, and you have profiles there as well. So that's very, very nice too. Okay, so besides that, okay, you got a shell inside the pod, but you can't do much there. It's just a small container, right? If you want to mine cryptocurrencies, you need to either compromise the cluster or compromise the whole cloud environment, right? So in this situation here, a great tweet from Duffy Cooley, which is now working at Isovalent, he mentioned that from this command, which is pretty simple, you can do a cluster, a Podscape, by deploying another pod that's privileged, right? So you're doing a pod or containerscape by deploying a privileged pod. So what's exactly happened here? And I'll try to describe what's it doing. So on the left side, I have this his tweet, and on the right side, I basically have the command broken down into a JSON format so that we can talk about it. Okay, so let's unpack this a little bit, right? So the kubectl gets as a pod with a container, but the overrides arguments make it special, right? So overloads the spec with a partial set of values parsed from the JSON, right? So first we see the host PID here equals true, right? Which breaks down the most fundamental isolation of containers, right? Letting us see all the processes as if we were in the host, right? Next, there is the ncenter command to switch to a different mount namespace. Whichever the one init is running in, right? So since that's guaranteed to be the host mount namespace, the result is similar to doing a host path mount and routing into it, right? The privileged security context is necessary to prevent permissions error accessing the proc /1/ns in smount, right? So be very careful about that. That still works, and that tweet is from 2019. Some managed Kubernetes servers might complain about that, might break your cluster. So don't try in your production environment. Make sure that you have a testing environment that you can do that. And another note is that doesn't work on OpenShift, which is an enterprise version of Kubernetes from Red Hat, right? Because of pod security policies. And we're going to talk about PSPs later on the slides if we have enough time. So let me move on here. Okay, so now we attacked a cluster, right? We compromised a pod from a web application vulnerability. We got access, we got a shell, and then we escaped the cluster through this privilege escalation here by container escaping, right? And get access to the node itself, right? And that's very fun, very cool. I know it needs some prerequisites for the cluster to be misconfigured for you to do that. So those are not the scenario that you can see by default, at least on the latest Kubernetes versions. But be very aware that there are many clusters out there that are outdated, and they could be vulnerable to those attacks. Another thing to be very careful is exposing your etcd, and I'm going to talk about that in a second too. Okay, so how can I defend that? Right? How can I protect my cluster from attacks? Isn't Kubernetes secure by default, right? Where do I start? Okay, so the main thing here, as I said before, is worry about your kubeAPI server first. Make sure that's not exposed, and if it is, if you really need that exposed, you have tight permissions, especially on your configuration of your kubeAPI server, but also your RBAC, which I'm going to talk a little bit in a second here. So one of the great things that helps protecting your cluster and understanding how the best practices of Kubernetes is the CIS Kubernetes Benchmark, right? So you have this great document from CIS that's a prescriptive guidance for establishing a secure configuration posture for Kubernetes, right? You have over 120 security controls, security checks for your cluster. And it was created by Kubernetes and cloud native security professionals such as Rory McCune, which is speaking here today as well, I think, and Liz Rice and many other contributors, right? So this document is very great. It has a lot of details, and it might be scary at first because it's a very long PDF document. But the reason being is that it tells you why you should set that permission or the configuration like it should, why it should be like that. It tells you the exact command for you to check if that's properly set or not. And it even tells you how to fix if that's not properly set, right? So it's very detailed, very descriptive, right? But I know There's also specific ones for EKS and GKE, but I know that that might not be feasible for you to go each by control, verifying that manually, right? So what's interesting is that there is a tool for that, for automating that check. And that's also a tool open source and provided by Aqua Security that checks the Kubernetes is deployed security. So it does all the checks right away for you once you point to your cluster. So here's just a sample output for a Kubebench results. As you can see, my cluster wasn't properly configured and a lot of fails from those checks, right? Okay, another thing that you need to worry about, right? And we've been talking about supply chain attacks and SolarWinds and Code Cov, right? So you need to understand what your containers are running, right? Especially your base images, right? So you should scan them for against vulnerabilities, right? Protect your pipeline against supply chain attacks. So those are some tools that are either free or open source that you can use for scanning them. Try out, see what works for you. And yeah, if you want to learn more about that, those tools and my opinion about them, just let me know and we can talk more about it. But those are great tools to start. Another tool that you need to, another protection that you need to have on your cluster, right, is about the container runtime, right? So you scan your images, right? You deploy that in your cluster and they're running. And what happens next? How do I know if an attacker was able to compromise? For example, in the scenario that we mentioned, how do I know that the attacker was able to get a shell inside the vulnerable pod, right? Which was running the vulnerable web application, right? How do I know that? So that's why I need some runtime protection. And I think that the best tool out there that's open source is Falco, which is also a tool that is part of the CNCF, right? The Cloud Native Computing Foundation, which Kubernetes belongs to as well. So what Falco does, Falco parses Linux kernel syscalls at runtime. So that's very, very interesting, using a technology that's being used a lot in container security tools, which is called eBPF, right? Enhanced Berkeley Packet Filter. I highly recommend if you want to know about the low levels and runtime protection about containers and Kubernetes. I highly recommend that you check it out. It detects unexpected behavior on your cluster, right? So it has a rule engine, which you can easily create rules using YAML files to detect any kind of behavior. So for example, if there is a new CVE published for Kubernetes or a tool that you're using on your cluster, you can quickly write a rule for that and apply that on your cluster. It also generates alerts based on the threats detected, right? And it uses an easy and powerful rules engine. So it's easy to develop new tools and new rules and apply that to your cluster. So I highly recommend that you check it out. One thing that Falco does is, and it does well, right, is protecting the runtime and making sure that any kind of drift, right, you can have some drift detections, anything that changes on your container after it was deployed, right, it alerts you, right? So you shouldn't have your like SSH running or something, a new package installed in your container after that's deployed to the cluster, right? You should generate a new container and deploy that, right? Okay, I have 5 minutes, I think, yeah. So on the pods itself, right, just you need to worry about your resources, right? Same thing applies for basic for containers as well. You don't want your containers fighting for resources, CPU and memory, so you can apply that. And it's also avoiding kind of a denial of service attack or self-denial of service attack if you don't do that, right? There's also a security context which you can apply to your pods and your containers as well. So some of them are recommended here, which are the allow privilege escalation set to false, right? So you don't want your container being able to escalate privileges, right? The read only root file system set to true, right? So you don't want your root file system being writable, right? So that's why you have that. You should add that setting there to your security context. And run as non-root set to true as well, right? You don't want your containers as much as we've seen out there, there are many situations where that's needed, but you usually don't want your container running as root. The pods here, I'm not going to talk about each specific security setting, but those are Linux kernel security settings that you can apply to your containers and to your cluster as well. So you have seccomp, AppArmor, and SE Linux. Just take a look at those and see what they do and what works best for your cluster. Make sure that also that whatever is set on your Docker containers Kubernetes doesn't inherit that. So you need to apply that again on your Kubernetes YAML file. So be very careful with that. So we used to have pod security policies, and we still do, but they're being deprecated. And that's why I want to take a minute to talk about that. So basically, a pod security policy was a security context that you could apply on a cluster level, right? And so you have a lot of security settings and definitions here that you were able to apply that to the cluster. Unfortunately, that PSP never went GA on Kubernetes, and it was hard to manage and to configure. So they decided to deprecate that on the latest version, I think 120 or 121. And now they're working on a new pod security policy, which is called pod security for now. And what does that mean? What's pod security policy, right? So we talked about the containers and we talked about the runtime, right? There's something in the middle there that's not checking the images and the pods that you're deploying the cluster, right? And that's the admission, that's the function of the admission controllers, right? Admission controller does exactly what the name says. It controls the admission of pods inside your cluster. And PSP is one of those admission controllers, which you can use to check, okay, if you're deploying this pod into this cluster, has it been scanned for vulnerabilities, right? Does it have any critical or high vulnerability? Then you can block it from joining your cluster. If it's all good, if it's green, then yeah, it has only a few low vulnerabilities, it's fine. Your policy allows that. So you allow that to join at that pod to join your cluster. So that's what pod security policy used to, it does right now, but it's being replaced for a new version, better version, easier to use. But you also have some alternatives there. You have Opa and you have Gatekeeper, right? We just saw a presentation about Opa, and I'm not going to talk about Opa that much. Ash did a great job talking about that. So go check it out. If you didn't see, go check out the recording. But you also have Kiferno, which is another solution, another tool that you can use on your Kubernetes cluster to create policies as code to apply to your cluster and decide which should go into your cluster, which pod should go into a cluster and which shouldn't, right? And the difference between Opa and Kiferno is that Kiferno doesn't require a separate language like called Rego for Opa. It doesn't require that. It uses the YAML files and YAML configuration to create those policies, right? Of course, there are some pros and cons between those tools, and I recommend that you check them out check them both out, right? So that you can compare and see what's best for your cluster. And this is the new pod security policy, the PSP replacement link, which has been accepted into Kubernetes. And I think they're working on the kind of the implementation now, but the design and the architecture, how that's going to work, that's already done. Already almost out of time. Let me see here. RBAC is something that's enabled by default on your clusters right now, and it's basically a role-based access control, similar to any other web applications, right? You have that, you have admin row, you have user row, you have manager row. So RBAC is something that that you can enable. That if it's not enabled on your cluster, if you're using previous versions, you should enable and apply that as well. So due to the time that I have here, I'm not gonna talk about everything, the new objects about RBAC here. So let's move on. Oh yeah, the etcd is something that's very important. The etcd is the heart of your cluster, right? It's the data, the key value store, the database of your Kubernetes cluster, right? It's the main storage location there, and all the cluster objects are saved there. And still, and still there are some scenarios that the etcd is being exposed to the internet, and you don't want that, right? Because the etcd has an API, and if you expose that to the internet and attackers can get to it, they basically can become cluster admin, right? Because if they can change the etcd, the way that Kubernetes works with the desired state, if I change something on etcd, my Kubernetes cluster will see that change and will apply that change to the cluster, right? And so basically I can deploy a privileged pod, I can get all the secrets, basically everything. So be very aware. We did a research a few months ago, and we checked on Shoda, and there's over 2,600 exposed etcd on just Shoda alone. And besides, there are other tools that you can check too. Okay, I think I'm out of time. How am I doing, Frank?
Hey, Magno, just, yeah, feel free, go ahead and take a couple more minutes. You know, I know
Okay.
you have just a few slides left. So
Yes.
hey, you're doing a great job here. So yeah, just do a couple more minutes and then we'll wrap it up.
Okay, sounds good. Thank you. Okay, so moving on, we also have network policies, and I'm not sure if everyone is aware of that, but Kubernetes by default, all the pods can communicate with any other pods in the cluster, right? So it is a flat network, right? You can see that that's a nightmare for security people, right? So make sure that you create a proper network policy for your cluster. If you're using a managed environment, sometimes the CNI or the container network interface might not support network policy. So you either need to change that or use other options, right? So for example, on the EKS, the AWS CNI for EKS doesn't support that. So you now can use, instead of network policies, you can use the security groups to your pod. So that's pretty cool. Right. So one question, some of the questions that you may ask, right? Does the front end pod really need to talk to the database pod, right? No, it should talk only to the backend, and then the backend talks to the database, right? So you're creating those network policies, network segmentation. That's very important, right? And what if an attacker can access the pods on the kube system namespace, right? I didn't say that, but kube system namespace is the main location of the pods of the control plane, right? The main pods there. So that's very sensitive information, and you don't want that. So there is a network policy editor that's created by Cilion. It makes it easy for you to create your own network policies. And yeah, besides that, audit logs. Audit logs are not enabled by default, right? And it's highly recommended that you enable them for security and troubleshooting, right? You want that so you can, I know that Kubernetes logs can be very verbose, but you want those audit logs, especially for security, right? And it's easy to set them up, right? And in the easiest way, if you want to just save the logs on your control plane, which is not recommended, by the way, but you just need a log path and a policy file, right? You can set those up on the Kube API server for configuration. So I highly recommend that you set those logs, and you can send that to a centralized location and monitor that with your SIEM, either Elk Stack or Splunk, whatever. But do check those logs because they have a lot of information that can tell you that somebody is messing with your cluster, something is going on, right? So that's highly recommended. Besides that, the basics, right? To wrap up here, update your Kubernetes environment version early and often. We used to have 4 Kubernetes releases a year. I think now we're going to have 3. The latest version is the 1.21, right? Don't use cluster admin for your daily work, right? So treat it like root. Excuse me. So if you don't use root daily, don't use the cluster admin role for your Kubernetes cluster, right? If you can, use managed Kubernetes service like AKS for Azure, EKS, or GKE, right? Why that? If you don't have any kind of compliance issues or you're like government entity, right? So with those managed services, you don't need to worry about the control plane because your cloud service provider takes care of that, and they have security defaults for those scenarios, right? So that's easier for you. You don't need someone to manage all that. And check out the Kubernetes benchmark document for more security best practices. I think that concludes my talk, and thank you everyone for joining. I'll be available on Slack for any questions.